All right, so in this lesson, what we talked about was the heat that's involved in state changes. So as a quick review, look, this is my heating curve for water. At the very bottom, I have a very cold solid. If I start adding heat to this system, what's going to happen is the temperature of the solid is going to increase until it hits 0 degrees for water. It's still a solid here, but then at this flat point, what's happening is the solid is becoming a liquid, and that is occurring at the melting point for water. If I keep adding heat, the liquid's going to increase in temperature until it hits 100 degrees. At 100 degrees, the liquid's going to transform into a gas. And so that is known as my boiling point of water, 100 degrees Celsius. And then finally, the temperature of the gas is going to increase. Okay? So a quick note, there is heat involved in each of these individual stages of the heating curve, but what we're going to be focusing on in this lesson is solid to a liquid, and then a liquid to a gas. Keep in mind, when you are moving from left to right, melting in that case, or when I am vaporizing, as I call it, or boiling is fine in this case, that requires heat. So the heat that you get is going to be positive. When you go from right to left, when I go backwards, heat is actually going to be released, causing it to be a negative value. So it's going to be negative when it goes that way, positive when it goes this way. Last concept, when I'm dealing with the heat, when I'm trying to calculate the heat that's involved in melting or freezing, we use what's called the heat of fusion. Meanwhile, when I'm vaporizing or condensing, I'm going to use what's called the heat of vaporization. All right, let's look at the first example. It says calculate the amount of heat change in kilojoules when 10 grams of benzene condenses, and it gives me my heat of vaporization here. So my given here is 10.0 grams. Notice I want to get into kilojoules. In order to get into kilojoules, I need to use my heat of vaporization, but the units for my heat of vaporization are kilojoules per mole. So the first thing I have to do is I have to get out of grams and I need to get into moles. Once I'm in moles, then I can get out of moles and I can convert into kilojoules. And that's what I'm asking for, kilojoules, so I'm good to go. Let's plug in these relationships. Grams to moles. To go from grams to moles, I need the molar mass of benzene, which is C6H6. Okay, so the molar mass of carbon is 12.011. I need to multiply that by 6 because I have 6 carbons. And I'm going to add to that the molar mass of hydrogen, which is 1.008 times 6. So the molar mass I get for benzene is 78.114 grams for every 1 mole. Then for here, my heat of vaporization is 30.8 kilojoules for every 1 mole. Now there's one thing that we need to note. Should this be positive or negative? Remember, if I'm going from left to right, if I'm going in the forward direction, my heat of vaporization or my heat of fusion will be positive. If I'm going in the opposite direction, it's going to be negative. Well, I'm talking about condensation here. I'm going from a gas to a liquid. So because I'm going backwards, my heat needs to be negative. Heat is going to be released by this process of condensing. Okay? So now I can just plug in my value. So 10 divided by the molar mass of benzene, 78.114. And then I'm going to multiply by negative 30.8. And I get negative 3.943. Okay? 10.0 has 1, 2, 3 sig figs. This has 5 sig figs, 3 sig figs. So I'm going to want 3 sig figs, 1, 2, 3. So I have negative 3.94, and my units are kilojoules. All right, let's look at the last problem. It says, calculate the amount of heat in kilojoules needed to melt 5 moles of water. Notice, this is my given, so I'm going to start with 5 moles of water. Okay. However, in order to get into heat, since my heat of fusion is 334 joules per gram, I first need to get out of moles and I need to get into grams. Once I'm in grams, then I can go from grams and get into joules. Then once I'm in joules, I can go from joules and get into kilojoules. Okay, so let's do that. Molar mass of water, because I've got to go from moles into grams. Well, I've got H2O for water. Hydrogen has a molar mass of 1.008 times 2 plus the molar mass of oxygen, which is 15.999, and I get a molar mass of 18.015 grams for every 1 mole. The heat of fusion here is 334 joules for every 1 gram, and then I know that 1 kilojoule is 10 to the 3rd joules. I'm going to go back really quickly and make sure that my heat of fusion here, 334, should in fact be a positive value. Okay. Well, since I am melting, I'm going from left to right. So I'm adding heat to the system. So yes, it should be a positive value. So when I do this, I get 30.08. Okay, I need to round to the correct number of sig figs. Well, 5.0 has 2 sig figs. This has 5. This has 3, so I need 2 sig figs here. So I'm going to keep 3 and the 0. So when this rounds, it's going to round to 30 point, so that I have 2 sig figs, and my units are kilojoules.